Bismillah Rahman Rahim. In this session, we will discuss question number 11 and 12 from exam exercise 9.10. The topic is trigonometry from additional mathematics course, and this book is written by Sue Pemberton, and this is very popular book. From this book, exercise number 9.10, question number 11 is here, and we have to show that this left hand side sec square theta minus 1 under root plus cosec square theta minus 1 under root is equal to sec theta cosec theta. This is a 5 marks question, and we have to show that. So we take the left hand side. We are taking left hand side. This sec square theta minus 1 is tangent square theta, and we know that cosec square theta minus 1 is cotangent square theta. So this becomes tangent, and this cot square theta under root is cot theta, and this tangent theta is sin theta upon cos theta plus cos theta upon sin theta. We take the LCM, and from LCM we have this is sin square theta plus cos square theta. We take the LCM and divide by this and multiply this to get this, and similarly we divide this and get this one and multiply by this to get sin square theta, and this is 1 upon cos theta sin theta. Cos theta is sec theta, and 1 over sin theta is cosec theta. So this is our right hand side. So we have taken this left hand side and we have obtained this right hand side. So this is part 1, and we have solved it. Now question number 12, solve the following equations. 4 sin 2x plus 5 cos 2x is equal to 0 for 0 to 180 degrees. So for this part we have this 4 sin 2x is equal to minus 5 cos 2x, and by rearrangement we have this sin 2x upon cos 2x is equal to minus 5 upon 4, tangent 2x is equal to minus 5 upon 4, 2x is equal to tangent inverse minus 5 upon 4. We know that tangent is negative in second and fourth quadrant, so this is second quadrant and fourth quadrant. We have obtained it, and from there since we have to solve it for 0 to 180 degrees, so we are solving it for 2x. So we can take up to 2x value, so it becomes 360. So we have this value, and once we have obtained for 2x, x is equal to divide by 2. So we have these two values. So this is our solution, and I'm just plotted it for better understanding. So we have just plotted this 4 sin 2x and 5 cos 2x separately, and then add it. So 4 sin 2x and 5 cos 2x, and we then add it to obtain this graph. 4 sin 2x plus 5 cos 2x, this blue line, and this is 0. So this is intersecting at these 2 points. So this is our solution. So this is 64.33 here and 154.33 here. So we have these two solutions, 154.33 here. This is 160, so this is 154.33. So this is all. In a part 2 we have cot square y plus 3 cosec x cosec y is equal to 3. So for 0 to 360 degrees, so we have taken this, and we have write down this cot square y is in terms of cosec square y minus 1 plus 3 cosec y minus 3 is equal to 0. And now we can write down by simplification. We got this. Now we can factorize it. So we have factorized this to obtain this. Either this is 0 or this is 0. If this part is 0, then we can write down cosec y plus 4 is equal to 0, and eventually sin y is equal to minus 1 upon 4. Cosec y is minus 1 is equal to 0. Cosec y is equal to 1. Sin y is equal to 1. Y is equal to sin inverse 1. So here this sin y is minus 1 upon 4. It is minus in the third and fourth quadrant. So third quadrant and fourth quadrant we have obtained these two solutions, and sign is in the positive in the first and second quadrant. This is the border of first and second quadrant, 90 degree. So y is positive. So we have these three solutions, 90 degree, 194.5 and 345.5. So we have this. three solution. Just plotted it. We plotted this value, cot square y plus 3 cos x y minus 3 is equal to 0. We have just plotted this one. Plotted it, and as a result of plotting, we have obtained this blue curve is this cot square y minus 3 cos x y minus 3, and equated with 0. So the intersecting points are the solution. So this is 90 degree and 194.5 degree and 345.5 degree. Yeah. So three solutions can be seen, and we have to solve an exam up till here. I have plotted it just for my understanding or understanding of the student, where they can understand why we have number of solutions. Why do we have 3 or 4 or 5 or 8 number of solutions? So this plotting gives a better idea. So that's why I'm plotted it, so that in a practice session we can build our concept by learning all these things, or dig out all the problems or explore it. So this eventually helps out in a A-level and higher educations. So in part 3, cos z plus pi by 4 is equal to minus half for 0 to 2 pi. So we have to plot it for this range. So z plus pi by 4 is cos inverse minus 1 upon 2. So we know that cos is negative in third and fourth quadrant for 0 to 2 pi. So we have write on this in a second and a third quadrant. So z is equal to, we will subtract this part from here. So z is obtained as 5 pi by 12 and 13 pi by 4. Simple calculations. And we have these two solutions. And we know we have this minus for 0 to 2. So two solutions should be there. And we have obtained, and the value is obtained as this value with z pi plus pi by 4. We'll subtract pi by 4 from each one, and we'll have this z value. So because we have to find the value of z where this equation satisfies to this. So we have obtained these two, and we have just cos z plotted. This is not required, and this is also not required, but we have just plotted it to show the results. So this gives the results. So here we have this minus 0.5 intersecting at minus 0.5 at 5 pi by 12, here 5 pi by 12, and 13 pi by 12 here. After pi, this is 13 pi by 12. This is pi. So we have these two solutions in this graph. So this is all from question exercise 9.10, and we will solve some other exercises in the next session.